Good morning. Welcome to the lecture session on vector calculus problems. Today we are going to discuss about what is vector differentiation, the topics or problems on the vector differentiation. So, first problem is find divergent curl for the vector point function f is del of x y cube x square x cube at the point 1 minus 1 1. Given the vector f is equal to del of x y cube into x z square. Let's call this as equation 1, and let phi is equal to x y cube into z square. So f implies it is del of phi, or dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. So f is equal to the derivative of this phi with respect to if we do, it is going to be y cube z square into I plus 3xy square z square j plus 2xy square z into k. Next, what is the divergence of f? The divergence of f is given by del dot of f. So the formula for del dot of f is dou by dou x of I plus dou by dou yj plus dou by dou z of k into the component of f. So when we do this, I dot I is 1, we know that j dot j is also 1 and k dot k. So respectively multiplying the I components and j k components, and then respectively differentiating with respect to x, y and z, that is dou by dou x of y cube z square plus dou by dou y of 3xy square z square plus dou by dou z of 2xy cube into z. And since in the first term we don't have a next term, it will become 0. And in the second term we have a y square term. If we differentiate it, it will become 2 into y. So when we multiply 2 to this, it will become 6xyz square plus, and we have a z term here. When we differentiate this z term, it will become 1. So we get 2xy cube. So the required du f is given by this. Coming to the curl f. The curl f formula is given by the determinant. So, but here we need to find out what is du f at the point 1, minus 1 and 1. Therefore, substituting x is equal to 1, y is equal to minus 1 and z is equals to 1. On simplification, we are getting du f is equal to minus 8. Next, let's go to the curl f. The curl f is given by del cross of f, that is the determinant with the first row I, j, k, the second row is dou by dou x, dou by dou y and dou by dou z, and the third row is the components of the f, that is y cube z square, 3x square y, 3x cube y square z square, and 2xy cube into z. These are the components. So when we do the curl f, we need to simplify by using the determinant, that is I times of dou by dou y of 2yx cube z minus dou by dou z of 3x square, and minus j times of, leave the column and row, we get dou by dou x of 2xy cube z minus dou by dou z of y cube z square plus k times of, leaving this, dou by dou x of this 3x square and dou by dou y of y cube z square. So on doing all this and putting the value of x, y, z as 1 minus 1 and 1, we get the curl f as 0. Let's go to the next question. If f is given by grad of x cube plus y cube plus z square minus 3xyz, then find du f and curl f. Given f is equal to grad of this, let's call this as 1, and phi is x cube plus y cube plus z cube minus 3xyz, and which implies f is del phi. So dou phi by dou xi plus dou phi by dou yj plus dou phi by dou z of k. That is, phi need to be differentiated with respect to x and multiplied with I, with respect to y, and then j, with respect to k, z, and then k. So when we do that, we get this result. Now let's find out what is du of f, the divergence of f. It's given by dou x of I plus dou y of j plus dou z of k into the f what we have obtained here will be substituted. Now respectively multiplying the ijk components and all that, we will be getting like last problem. Du f is 6x plus 6y plus 6z, and this is the answer. Similarly, for the curl f, we have del cross f. The determinant is ijk, dou x, dou y, dou z, and the components of f. This on simplification or by the determinant formula, we get the curl f as 0. Show that the next problem, f is equal to xi plus yj divided by x square plus y square is solenoidal and irrotational. In order to prove that it is a solenoidal, we need to prove that du f is 0. To prove that it is irrotational, prove that the curl f is 0. So we first determine what is du f, and it has to be 0 in order to prove that it is a solenoidal. And later we will find the curl f, so that which will also be equal to 0. It shows that it is irrotational. So f is given by xi plus yj divided by x square plus y square. So separating the I term and then the j term, we get this one. And of course the k term is not there, so we will write it simply as 0 into k. So du f is given by dou xi plus dou yj plus dou zk of the xi component, j component, and then the k component, where k component is 0. So dou x of this I component plus dou y of the j component, dou z of k component, which is 0. And when you are determining dou x, we have numerator and denominator, both terms are having x. So we need to apply the quotient rule, that is x square plus y squared into derivative of x, that is 1, minus x into derivative of x square plus y square with respect to x. If you do, it is only 2x divided by the denominator whole square. Similarly, x square plus y square into 1 minus y into 2y divided by x square plus y square the whole square. And here what do we get is y squared minus x square, and here we will be getting x squared minus y square. So both the terms will get cancelled since the LCM is same. We can observe y squared minus x square on simplification, and here x squared minus y square on simplification. When we take the LCM and adding y square minus x square plus x square minus y square, which will be 0 on the numerator, that is du f is 0. When the du f is 0, f is solenoidal. Now let us prove that the vector is irrotational. In order to prove that it is irrotational, consider the determinant having ijk as a first row, dou x, dou y, dou z is a second row, and the third row is the components of it. And which on simplification, I times of this 0 minus j times of 0 plus k times of this, we get it. Of course this also will be 0 because 2xy minus 2xy will be equals to 0. So curl f is equals to 0, and it shows that f was a irrotational. Next problem, show that the vector is an irrotational. So in order to prove that it is an irrotational, what we need to do is, we have to show that the determinant is equals to 0. So consider the ijk components as the third row. First row is ijk, second row is dou x and dou y, dou z, and the third row is the components of ijk. And simplify the determinant, that is I into dou y of this minus dou z of y square minus zx, and so on. If we do that, we are getting 0I plus 0j plus 0k, that is curl f is equals to 0. So when the curl f is equals to 0, we say that f is an irrotational. So this proves it is a irrotational. Thank you.